Welcome. In this notebook, we're going to break down CI/CD, or continuous integration, and continuous delivery, or deployment, in a way that's clear, structured, and practical. We'll start with the basics. What is CI/CD, in simple terms? What are continuous integration and continuous delivery, and how do they work together? Then, we'll look at the key benefits of using CI/CD in modern software development. Next, we'll dive into core concepts like the CI/CD pipeline, what it looks like, and the typical stages involved. From there, we'll explore the tools that make CI/CD possible. Popular CI tools like Jenkins and GitHub Actions, CD tools like Argo CD and Spinnaker, and supporting tools like Docker, Kubernetes, Helm, and Terraform. We'll also cover how CI/CD integrates with version control, especially Git, looking at commits, branches, and pull requests. Then we'll see how automation works through webhooks and triggers, and how testing fits in, from unit tests to full end-to-end tests, and how pipelines give fast feedback through test coverage reports. After that, we'll look at build and artifact management, including how to package your app and store artifacts in platforms like Docker Hub or GitHub packages. We'll explain environment management, from development to production, and how to handle configuration files and secrets securely. We'll also touch on infrastructure as code, and how tools like Terraform or Ansible help automate deployments. You'll also learn about deployment strategies, manual versus automatic, blue-green, canary, and rolling deployments, plus how to handle rollbacks and errors safely. Finally, we'll explore monitoring and feedback, using logs, metrics, and alerts, and tools like Prometheus, Grafana, Elk, and Sentry. We'll wrap up with security best practices, managing secrets, scanning code for vulnerabilities, and using code signing and approval workflows to enforce trust and safety. At the final section, you also get some insights about which tools and concepts are more important for developers to learn. By the end of this session, you'll have a full understanding of how modern software teams use CI/CD to ship code faster, safer, and more reliably, and how you can start applying those practices in real development environments. Let's get started.
What is CI/CD in simple words?
Imagine this scenario. You're working in a team of developers. Everyone is writing code at the same time. You need a way to make sure everyone's code works together. Test the code automatically. Push the app live without breaking anything. That's where CI/CD helps. CI/CD stands for Continuous Integration and Continuous Delivery Deployment. It's a method used by software teams to build, test, and release code more frequently and reliably.
Continuous integration, CI.
Every time a developer writes code and pushes it to the shared repository, like GitHub, a CI tool will automatically pull the latest code, build the app, compile, install packages, etc. Run automated tests, like unit tests. If something fails, like a test, it alerts the team immediately. The goal here is to catch problems early and make sure new code works with the existing code base.
Continuous delivery, CD.
Continuous delivery, or CD, is the practice of automating the entire release process so that code changes can be deployed to production at any time, quickly, safely, and with minimal manual effort. In a continuous delivery setup, every code change goes through automated testing, building, and staging, and then lands in a state where it's ready for deployment. This doesn't mean it's deployed right away, but it's deployable at any time, with the press of a button or an automated approval. By minimizing manual steps, CD helps teams avoid delays, reduce errors, and eliminate bottlenecks in the release cycle. That makes it possible to ship fast and reliably, whether that's once a week or several times a day. Ultimately, continuous delivery gives teams the confidence to release frequently, knowing that the pipeline has tested, validated, and prepared everything in advance. It's a key component of modern CI/CD pipelines, helping organizations move from slow, risky releases to fast, repeatable, and safe delivery workflows.
Benefits in modern software development.
Continuous integration and continuous delivery bring major advantages to development teams and businesses. First, they help deliver new features and bug fixes faster, thanks to automated build and deployment pipelines. Second, because code is integrated and tested frequently, bugs are found and fixed early, long before they become costly problems. Third, they boost collaboration and accountability. Every team member regularly commits code, which makes everyone responsible for the health of the product. Fourth, deployments become reliable and repeatable. Teams can push changes to production with confidence. No more "it works on my machine" issues. Fifth, product quality improves. Automated tests ensure that each change meets defined standards before reaching users. Sixth, many manual steps are automated, reducing the risk of human error and saving time for more creative work. And finally, feedback loops are shorter. Developers see the results of their changes quickly, which helps them iterate and improve rapidly. In short, CI/CD transforms software delivery into a fast, reliable, and scalable process that supports modern development needs.
Key CI/CD concepts.
Key CI/CD concepts represent the steps in the automated software delivery pipeline. The process starts with building and testing code, then integrating it into the main project. Delivery gets the software ready for deployment, which is then released to users. Monitoring ensures any issues after deployment are caught and addressed quickly.
CI/CD pipeline. What is a pipeline?
A pipeline is an automated sequence of steps that takes code from development to deployment. Think of it like an assembly line in a factory, but for software. The process usually starts when a developer pushes code to a shared repository. That push triggers the pipeline automatically. From there, the pipeline typically includes these stages: build the code, test it with unit and integration tests, release it as a package, and finally, deploy it to production or a staging environment. This automation ensures that every change is handled in a consistent and repeatable way. Pipelines greatly reduce the risk of human error, speed up releases, and help developers get immediate feedback on their work. In short, a pipeline makes the development cycle faster, safer, and more reliable.
Typical stages in a pipeline.
Let's break down the typical stages in a CI/CD pipeline. First is the source stage. The pipeline is triggered by changes in the source code, usually through a git commit or pull request. Next comes the build stage. Here, the source code is compiled, dependencies are resolved, and build artifacts, like binaries or container images, are created. Then we have the test stage. Automated tests are run to verify that the new code works as expected. This may include unit tests, integration tests, and more. After testing, we move to the package stage. The validated code is bundled into a deployable format, like a Docker image or an archive file. The release stage marks the package as ready for deployment. This might include tagging the version or publishing to an artifact repository. Then comes deploy, where the application is delivered to staging or production environments. This step is often automated, but may include approvals in critical systems. Finally, there's the monitor stage. After deployment, tools monitor the application's health, performance, and user impact to ensure everything runs smoothly. These stages ensure a robust, reliable, and fully automated delivery pipeline that supports rapid and safe changes to software.
Tools in CI/CD. CI tools.
Now let's explore some of the most popular continuous integration tools used in the industry. First is Jenkins. It's a powerful, open-source CI tool that supports hundreds of plugins. Jenkins is great for teams that want deep customization and full control. Next is GitHub Actions. It's built right into GitHub and allows you to define workflows directly in your repository using YAML. It's especially convenient if your code already lives on GitHub. GitLab CI is tightly integrated with GitLab repositories. It provides a full DevOps lifecycle solution, including code, CI/CD, and monitoring, all in one platform. Travis CI is known for its simplicity and is widely used in open-source projects. It's easy to set up and integrates well with GitHub. And finally, Circle CI is a cloud-native CI/CD platform known for its speed and scalability. It's great for fast parallel builds and efficient pipelines. Each of these tools can automate your builds, tests, and deployments, so you can ship faster and with confidence.
CD tools.
First is Argo CD. It's a GitOps-based CD tool designed for Kubernetes. Argo CD automatically syncs your live environment with your Git repository, making deployments declarative, auditable, and safe. Next is Spinnaker. This is a robust, multi-cloud delivery platform used by companies like Netflix. Spinnaker supports advanced deployment strategies like blue-green and canary releases and works with cloud providers like AWS, GCP, and Kubernetes. And then there's Flux. Like Argo CD, it follows the GitOps model. Flux continuously monitors your Git repo and applies changes to your cluster, making it ideal for fully automated Kubernetes workflows. These tools help teams push code to production safely and consistently, with strong support for cloud-native infrastructure and deployment best practices. Let's talk about supporting tools that work alongside CI/CD to enable modern software delivery. First is Docker. Docker allows you to package your application along with its dependencies into a container. This makes it portable and consistent across environments. Next is Kubernetes. Kubernetes is a container orchestration platform. It helps you run, scale, and manage containerized applications reliably across clusters of machines. Then comes Helm. Helm is a package manager for Kubernetes. It uses something called charts to define, install, and upgrade Kubernetes applications, making deployment repeatable and manageable. Ansible is used for configuration management. It automates tasks like setting up servers, installing packages, and provisioning environments, all using simple, readable code. Finally, Terraform is a tool for infrastructure as code, or IAC. It lets you define cloud infrastructure, like servers, databases, and networks, in code that can be versioned and reused. Together, these tools support every part of the delivery lifecycle, from packaging and deployment to infrastructure and operations.
Supporting tools. Version control integration. Git basics, commits.
Let's start with the most basic Git concept, the commit. A commit is like a snapshot of your code at a specific moment in time. It records what changed, who made the change, and when. Each commit includes a unique ID, an author, a timestamp, and a short message explaining the change. Commits allow you to track the history of a project, review changes, and even undo mistakes if something goes wrong. They are the foundation of Git's version control system and make team collaboration structured and reliable.
Git basics, branches.
A branch is an isolated environment for your code. Think of it as a workspace where you can experiment or add features without affecting the main code base. The default branch is often called main or master. But when working on new features or bug fixes, you create feature branches. This keeps the main branch stable while developers work in parallel. Once the work is tested and complete, the branch can be merged back into the main line. This is how teams safely manage multiple changes at once.
Git basics, pull requests.
Finally, let's talk about pull requests, also known as merge requests. A pull request is a way to propose changes in one branch, usually a feature branch, to be merged into another, like main. It gives your team a chance to review the code, leave comments, and request changes before merging. Pull requests often trigger CI pipelines to run tests and checks automatically, adding a layer of safety. After everything passes and reviewers approve, the code is merged. This process promotes better collaboration and higher code quality.
Webhooks and triggers for automation.
Let's talk about webhooks and how they're used to automate the CI/CD process. A webhook is a way for one system to notify another system in real time when an event happens. It's like saying, "Hey, something just changed. Take action now." For example, when you push code to a Git repository, a webhook can trigger your CI/CD pipeline to start building and testing immediately. Webhooks can also respond to events like pull requests, merges, or tagging a release. This automation removes the need for manual intervention. Developers don't need to click a button to start a build. The system does it automatically. As a result, webhooks help make development faster, more responsive, and more efficient.
Automated testing. Unit tests, integration tests, end-to-end tests.
In automated testing, there are three main levels of tests you'll encounter: unit tests, integration tests, and end-to-end tests. Let's start with unit tests. These are the smallest and fastest tests. They check if individual functions, methods, or components work as expected, in isolation, without dependencies. Next are integration tests. These test how different parts of the system work together. For example, making sure your app correctly interacts with a database or API. Finally, we have end-to-end tests, or E2E tests. These simulate real user workflows, from clicking a button to seeing a result on the screen. They test the entire system from the user's perspective, and they tend to be slower, but very valuable.
Test coverage and fail-pass feedback.
Let's talk about test coverage and the feedback loop in automated testing. Test coverage measures how much of your code is exercised by tests. For example, if your tests run through 80% of your code, that's 80% coverage. Coverage reports help you identify which lines, branches, or functions are untested, so you can improve your test suite. When you push code, CI tools automatically run your tests and give you immediate pass or fail feedback. This is a critical part of fast development cycles. Failing tests stop bad code from going further in the pipeline. Passing tests confirm that recent changes haven't broken anything. This fast automated feedback helps teams fix issues early, reduce bugs in production, and build confidence in every release.
Build and artifact management. Creating build artifacts.
Let's now look at build artifacts, a critical part of the CI/CD process. A build artifact is the final output created during the build stage of your pipeline. This could be a jar file for a Java application, the Docker image for containerized apps, or a .zip or .tar.gz file. These artifacts are typically versioned and stored in a registry or repository, like Docker Hub, JFrog Artifactory, or GitHub packages. Once created, artifacts are reused in later stages, like testing, staging, and production, ensuring that what you test is exactly what gets deployed. Creating consistent, traceable artifacts is essential for repeatable builds and reliable deployments.
Storing artifacts.
Once we build our application, the pipeline produces artifacts, like jar files or Docker images. These artifacts are the exact binaries we'll later test and deploy. In a CI/CD workflow, storing these artifacts in a registry is crucial. Tools like Artifactory, GitHub Packages, or Docker Hub act as central hubs where artifacts are versioned, traceable, and ready for use in other stages of the pipeline. When the pipeline promotes code from test to staging or production, it pulls the exact same artifact, ensuring consistency and eliminating the "it works on my machine" problem. Artifact storage also enables rollback. If something breaks in production, the pipeline can quickly redeploy a previous known good version. This practice supports the core CI/CD goal, delivering reliable, repeatable builds across environments.
Environment management. Dev, test, staging, production.
In a CI/CD pipeline, software isn't built and deployed straight to users. Instead, it passes through a set of structured environments, each designed to reduce risk and increase confidence at every step. We start with dev. This is where developers push their changes, often to feature branches. CI tools pick up the code, run quick tests, and generate early feedback. Next comes test, where automated unit and integration tests run in a clean environment. If the build passes here, we know the code works as expected in isolation. Then we promote the same artifact to staging. This environment closely mirrors production and is used for final validation, like load testing, security scans, and user acceptance testing. It's the last checkpoint before real users see the change. Finally, if all checks pass, the pipeline automatically deploys the artifact to production, the live environment where the application runs for end users. By separating concerns across these environments, CI/CD pipelines can deliver updates frequently, safely, and reliably, without breaking what's already working.
Configuration files and secrets management.
As we move code through dev, test, staging, and production, the application often needs different settings for each environment. That's where configuration files come in. In a CI/CD pipeline, these files, like .env, YAML, or JSON, are injected automatically during deployment. They allow us to change things like database URLs or feature toggles without touching the source code. Now let's talk about secrets, which are sensitive values such as API keys, database passwords, or access tokens. In a secure CI/CD workflow, secrets should never be hard-coded in code or stored in version control. Instead, we use tools like Vault, AWS Secrets Manager, or Kubernetes Secrets. These tools integrate with CI/CD platforms to safely inject secrets into build and deploy jobs at runtime. Proper management of configuration and secrets is essential to building secure, portable, and environment-specific pipelines.
Infrastructure as code, IAC.
In CI/CD, automation doesn't stop at building and testing code. We also automate the infrastructure it runs on. That's where infrastructure as code, or IAC, fits in. IAC lets us define servers, networks, databases, and cloud resources as version-controlled code. Tools like Terraform, Ansible, and CloudFormation integrate directly with CI/CD pipelines to provision infrastructure on demand. This means we can spin up test environments automatically during pipeline execution, or tear them down when no longer needed, all from the same codebase. IAC ensures that every environment, dev, test, staging, and production, is consistent, repeatable, and traceable. It's a key part of delivering software at scale with reliability.
Deployment strategies. Manual versus automatic deployment.
In the CI/CD lifecycle, deployment is the final step, pushing the built and tested application to a live environment. There are two main ways this can happen: manual and automatic deployment. In manual deployments, a human decides when to release and triggers the deployment, usually by running a script or clicking a button. While this gives control, it's also slower and more prone to human error. It doesn't scale well for fast, frequent releases. In contrast, automatic deployments are integrated directly into the CD pipeline. Once all tests pass and conditions are met, like approvals or successful staging tests, the deployment happens without human involvement. Automatic deployments are a core benefit of CI/CD. They make the process faster, more consistent, and less error-prone, especially when rolling out updates across multiple environments. Some teams combine both approaches, using automatic deployments to staging and manual approval before going live in production. This hybrid model balances speed with safety.
Blue-green, canary, rolling deployments.
Once CI/CD pipelines build and test an application, the final challenge is deploying it safely, especially in production. That's where modern deployment strategies come in, designed to reduce risk, ensure stability, and support zero downtime releases. First, there's the blue-green deployment. You maintain two identical environments. Blue is live, green is idle. The pipeline deploys to green, and once verified, you switch traffic to it instantly. If something goes wrong, you simply roll back to blue. Next is the canary deployment. Instead of releasing to everyone, the pipeline rolls out the new version to a small percentage of users. You monitor for errors or slowdowns, and if all looks good, expand the rollout to 100%. This minimizes the blast radius of bugs. Finally, we have rolling deployments. The new version is deployed gradually, replacing a few instances at a time. It allows continuous monitoring during rollout without needing duplicate environments. All three strategies can be fully automated and controlled through the CI/CD pipeline, often using orchestration tools like Kubernetes and service meshes. These methods bring resilience, observability, and control to production deployments, key goals in any modern DevOps practice.
Rollbacks and error handling.
In any deployment strategy, blue, green, canary, or rolling, something can still go wrong. That's why rollbacks and error handling are essential parts of a robust CI/CD pipeline. A rollback means restoring the previous stable version of the application when an issue is detected, whether it's a crash, slow response time, or failed health check. In a well-integrated CI/CD system, rollbacks can happen automatically. For example, a monitoring tool might detect a spike in error rates after deployment and trigger a rollback within seconds. This minimizes user impact and maintains uptime. In other cases, rollbacks are manual but fast, enabled by using immutable artifacts stored in registries, like Docker images or jars. Since the pipeline already deployed the previous version successfully, we can redeploy it confidently. Error handling also includes setting up alerting, logging, and health checks, so the pipeline knows if something is wrong, and the team can respond quickly. Reliable rollback mechanisms are a core part of continuous delivery, making it safe to deploy frequently, even to production.
Monitoring and feedback. Logs, metrics, alerts.
Once the application is deployed, especially through an automated CI/CD pipeline, the next concern is how we know if it's actually working. That's where logs, metrics, and alerts come in. Logs capture detailed events inside the application or infrastructure, like errors, warnings, or user activity. They're useful for diagnosing issues after something goes wrong. Metrics, on the other hand, give us a high-level numeric view of the system over time, things like response times, memory usage, or error rates. They help track performance and trends at a glance. Then we have alerts, which are tied to specific conditions. For example, if error rates spike, CPU usage crosses a threshold, a deployment fails a health check. The CI/CD pipeline or monitoring tool can send an alert via email, Slack, or PagerDuty so the team knows to act. In some setups, these alerts even trigger automatic rollbacks. Logs, metrics, and alerts form the feedback loop of CI/CD. They make it possible to detect issues early, recover quickly, and continuously improve both the application and the pipeline.
Tools: Prometheus, Grafana, ElkStack, Sentry.
To complete the monitoring and feedback loop in CI/CD, we rely on powerful tools that specialize in metrics, logs, and error visibility. Let's look at a few of the most widely used. First, Prometheus. It's an open-source system that collects and stores time series metrics, like CPU usage, memory, or request latency. It works well with containerized environments and integrates smoothly into CI/CD pipelines. Next is Grafana, often used alongside Prometheus. Grafana provides beautiful, interactive dashboards that help teams visualize metrics and trends. It also supports alerting, so you can trigger Slack messages, emails, or rollbacks when thresholds are crossed. Then we have the ELK stack, Elasticsearch, Logstash, and Kibana. It's used for log aggregation and analysis. Logs from applications, pipelines, or infrastructure are collected, indexed, and made searchable. This is vital for debugging failed deployments or performance issues. Lastly, Sentry is a tool designed specifically for error monitoring at the application level. It integrates directly into your code and reports real-time exceptions with detailed stack traces, user impact, and contextual data. This gives developers immediate feedback after a CI/CD deployment. Together, these tools ensure that once software is deployed, you're never flying blind. They provide the visibility and feedback needed for fast, safe, and continuous delivery.
Security in CI/CD. Secrets management.
In a CI/CD pipeline, security must be treated as a first-class citizen, and that starts with how we manage secrets. Secrets include things like API keys, passwords, database credentials, and tokens. These are essential for builds and deployments, but they must be handled with care. Hard-coding secrets in source code or config files is a major security risk, especially in shared or public repositories. That's where secrets management tools come in. GitHub Secrets lets you securely store and manage credentials within a GitHub repository or organization. These secrets can be injected into CI workflows like GitHub Actions without exposing them in logs or code. For more advanced setups, HashiCorp Vault is a popular choice. It provides fine-grained access control, encryption, dynamic secrets, and audit logs, ideal for teams working across multiple environments and services. Other tools like AWS Secrets Manager, Azure Key Vault, and Kubernetes Secrets also integrate well into CI/CD pipelines. Secrets should be injected at runtime, only when needed, through environment variables or secure volume mounts. This keeps your pipeline safe, auditable, and compliant, even at scale. Managing secrets securely is not optional. It's foundational to safe and trusted software delivery.
Security scanning.
Security in CI/CD isn't just about secrets. It's also about proactively finding vulnerabilities in your code and applications. And that's where security scanning tools come in. There are two main types, SAST and DAST. SAST, or Static Application Security Testing, analyzes your source code or compiled code without running it. It looks for common security issues like SQL injection, hard-coded credentials, or unsafe code patterns early in the pipeline, often during the build phase. Tools like SonarQube, SemGrep, or GitHub Advanced Security are examples. On the other hand, DAST, or Dynamic Application Security Testing, scans your app while it's running, usually in a staging environment. It simulates attacks from the outside, like a real hacker would, and checks for vulnerabilities, such as broken authentication or exposed endpoints. Tools include OWASP, Burp Suite, and others. Integrating both SAST and DAST into your CI/CD pipeline ensures you catch security issues early and often, instead of after a breach. You can even configure pipelines to fail builds or block deployments when high-severity vulnerabilities are detected. By treating security scanning like testing, automated and continuous, you build software that's not just functional and reliable, but also secure by design.
Code signing and approval workflows.
As software moves through a CI/CD pipeline, especially toward production, we need strong validation that the code is both authentic and approved. That's where code signing and approval workflows come in. Code signing uses cryptographic keys to sign binaries or artifacts, like Docker images or jars. This ensures that the artifact hasn't been tampered with and comes from a trusted source. It's critical in regulated industries or public software distribution, where verifying origin and integrity is a must. Approval workflows, on the other hand, enforce human or policy-based reviews during the pipeline. For example, pull requests might require code review and sign-off before merging. Deployment to production might require manual approval or multi-person review, depending on the risk level. These workflows help prevent unauthorized or unreviewed changes from reaching sensitive environments. In practice, this can be enforced through GitHub branch protection rules, GitLab merge request approvals, CI tools like Jenkins, Argo CD, or Spinnaker with gated stages. Together, code signing and approvals provide a security checkpoint in your CI/CD pipeline, ensuring only trusted and validated code makes it all the way to users.
Which CI/CD tools are necessary for a developer to know?
If you're a developer preparing to work in modern software teams, it's essential to get comfortable with the core tools that power CI/CD pipelines. First and most important is version control. Every developer must know Git. It's used to track changes, manage branches, and collaborate with others. Most teams use platforms like GitHub or GitLab to host Git repositories and manage pull requests and CI pipelines. Next is testing tools. Writing tests is a basic part of CI. Depending on your language, you'll use tools like Google Test for C++, PyTest or Unit Test for Python, or JUnit for Java. These tools help you write unit tests, integration tests, and even end-to-end tests, all of which are automated in the CI pipeline. Then we have build tools. These are used to compile and package your code. For example, Make or CMake for C++, Pip or Poetry for Python, and build tools like Maven or Gradle for Java. A very important CI/CD skill is Docker. Many pipelines use Docker to test and deploy apps in isolated environments. You should know how to write a simple Docker file, build Docker images, and run containers. It's one of the most portable and consistent ways to ship software today. Lastly, most CI/CD tools use YAML files to define pipeline steps. YAML is a markup language, and you don't need to master it, but you should know the basic syntax and indentation rules, because a misplaced space can break your build. Together, these tools form the foundation of a modern developer's CI/CD skill set. Learning them will prepare you to contribute effectively in almost any professional software team. Thanks for watching.